3,000 feet per minute, it plummeted. Air France Flight 447, with 228 souls, vanished into the vast Atlantic Ocean on June 1st, 2009. A flight from Rio de Janeiro to Paris. The advanced Airbus A330 200 aircraft was flying high at 35,000 feet through the equatorial region, a known zone for severe thunderstorms and treacherous ice crystal formations. Its critical pitot tubes, designed to measure airspeed, likely experienced total blockage from these ice crystals, giving erroneous data to the aircraft's computers. This false information caused the autopilot system to disengage at a critical moment, demanding immediate manual control from the two pilots on board. A profound cascade of errors then began to unfold within the cockpit environment. Instead of pushing the nose down to gain speed and recover from what was becoming a stall situation, the pilots repeatedly pulled the nose up further, worsening the aerodynamic stall condition. For 3 minutes and 30 seconds, the huge jetliner fell at an astonishing rate, often exceeding 10,000 feet per minute. A rapid, uncontrolled descent. The flight crew appeared disoriented regarding the plane's true airspeed and its altitude. No emergency distress signal was ever broadcast or received by air traffic controllers. The violent impact with the ocean surface was catastrophic, scattering debris over an enormous area. A monumental international search operation quickly began, involving naval assets and specialized vessels from several nations. The main wreckage field was eventually located nearly 2 years later, approximately 13,000 feet below the water's surface. A truly incredible depth. Robotic submarines, like the sophisticated Remus 6000, meticulously surveyed the seabed for many months, covering hundreds of square miles. The discovery of the flight data recorder and the cockpit voice recorder after almost 730 days was a monumental breakthrough. These black boxes were found nearly 13,000 feet down, an engineering marvel of recovery. Families of the 228 victims endured prolonged periods of anguish and uncertainty throughout the entire 2-year search phase. The subsequent accident investigation, a multi-year effort spanning over 4 years, uncovered a complex interplay of contributing factors. It highlighted significant deficiencies in pilot training, specifically relating to manual flying at high altitudes and handling unreliable airspeed indications. The over-reliance on automated systems, coupled with a lack of understanding of basic aerodynamic principles during an upset condition, proved fatal. This tragic event spurred significant changes across the global aviation industry. New training protocols for airline pilots were implemented, emphasizing upset recovery and practical manual flying skills. Aircraft manufacturers also modified flight systems and warnings to prevent similar recurrences. The total financial expenditure for the search, recovery, and investigation efforts easily exceeded 50 million euros, a truly staggering sum for such a deep water operation. The lessons learned from this disaster continue to shape aviation safety protocols, ensuring future flights are safer for millions of passengers worldwide. The final accident report detailed more than 30 individual factors that together led to the loss of the aircraft and all its passengers and crew. For 4 minutes, one pilot held the control stick fully back, preventing any recovery. Air France Flight 447's tragic final moments were a confluence of human and machine failures that cascaded over 3 minutes and 30 seconds. The investigation, spanning over 4 years, involved hundreds of experts from several countries, dissecting every detail of the 2009 disaster. The flight data recorder and cockpit voice recorder, recovered from nearly 13,000 feet beneath the Atlantic Ocean, provided an invaluable 688 parameters of data, Analysis revealed the captain was resting while two first officers piloted the advanced Airbus A330-200. One first officer mistakenly applied continuous nose-up input after autopilot disengagement, believing it was overspeeding when stalling at 35,000 feet. The stall warning sounding like a cricket chirping for 850 Hz, activated then deactivated, as airspeed data was unreliable below 60 knots, misleading the crew. The aircraft entered an aerodynamic stall at around 37,000 feet. 126 individual alarms sounded during the final minutes. The flight control system transitioned from normal law to alternate law, significantly reducing protections and leaving the crew with less automated assistance. This change was not explicitly clear to the pilots. Pilots' training deficiencies in manual flight at high altitude and upset recovery were critically exposed. Many pilots had relied heavily on automation for tens of thousands of hours. Post-accident reviews highlighted that pilots were logging an average of 60 to 70 flight hours per month. The incident led to 26 safety recommendations from the French Bureau of Inquiry and Analysis for Civil Aviation Safety, BEA, including improvements to stall warnings and pilot training. Airbus modified its A330 flight control computers with several software updates after the accident. For example, the stall warning logic was enhanced to activate reliably, even with unreliable airspeed data, and remain active throughout a stall. New training protocols were mandated globally, requiring pilots to spend additional hours in simulators, practicing manual flight, and recovering from unexpected situations at high altitudes. These new simulator sessions often included 2 hours of manual flying drills. Aircraft manufacturers like Taylor's and Goodrich also redesigned pitot tubes to be more resistant to ice crystal formation. The financial cost of the recovery and investigation was over 50 million euros, a huge sum for this unprecedented deep-sea operation that covered hundreds of square miles of seabed. 228 people tragically lost their lives that day. The profound lessons learned from Air France Flight 447 continue to shape global aviation safety standards years after the event, aiming to prevent future recurrences and save millions of lives. A single pilot held the controls fully back for 4 entire minutes. Air France Flight 447's tragic final moments unfolded as a confluence of human and machine failures over just 3 minutes and 30 seconds. The investigation, launched after the 2009 disaster, spanned over 4 years, involving hundreds of experts from several countries, diligently dissecting every minute detail. Its flight data recorder and cockpit voice recorder were miraculously recovered from nearly 13,000 feet beneath the vast Atlantic Ocean, providing an invaluable 688 parameters of critical data. Analysis showed the captain was resting, while 2 first officers piloted the advanced Airbus A330-200. One first officer mistakenly applied continuous nose-up input after autopilot disengagement. This action occurred believing the aircraft was overspeeding when it was in fact stalling at 35,000 feet. The stall warning, an 850 Hz sound like a cricket chirping, activated then deceptively deactivated as airspeed data proved unreliable below 60 knots, completely misleading the unaware crew. The massive aircraft soon entered an aerodynamic stall at around 37,000 feet. 126 individual alarms loudly sounded during those final minutes, creating utter chaos. The flight control system dramatically transitioned from normal law to alternate law, significantly reducing crucial protections and leaving the crew with less automated assistance than they were accustomed to. This critical change was regrettably not explicitly clear to the already stressed pilots. Pilots' training deficiencies in manual flight at high altitude and upset recovery were shockingly exposed. Many pilots had relied heavily on automation for tens of thousands of flight hours. Post-accident reviews starkly highlighted that pilots were logging an average of 60 to 70 flight hours per month. The incident led directly to 26 urgent safety recommendations from the French Bureau of Inquiry and Analysis for Civil Aviation Safety, BEA. These included vital improvements to stall warnings and comprehensive pilot training protocols. Airbus promptly modified its A330 flight control computers, with several imperative software updates after the devastating accident. For example, the stall warning logic was greatly enhanced to activate reliably, even with unreliable airspeed data, and importantly, remain active throughout an entire stall event. New training protocols were globally mandated, requiring pilots to spend additional critical hours in simulators, practicing manual flight, and recovering from unexpected situations at very high altitudes. These new simulator sessions often included 2 hours of intense manual flying drills to build proficiency. Aircraft manufacturers like Thales and Goodrich also ingeniously redesigned pitot tubes to be far more resistant to dangerous ice crystal formation, a contributing factor. The financial cost of the recovery and the exhaustive investigation alone was over 50 million euros, a truly huge sum for this unprecedented deep-sea operation that meticulously covered hundreds of square miles of unforgiving seabed. 228 innocent people tragically lost their precious lives that dreadful day. The profound lessons painstakingly learned from Air France Flight 447 continue to powerfully shape global aviation safety standards years after the event, aiming to prevent future recurrences and ultimately save millions of potential lives across the world.